In this video, we are going to discuss various components that we often find in time series. There are various kinds of patterns that we can find in many time series and that come together in the data. From these patterns, we often find many of them at the same time in any given time series. We are going to learn to identify these patterns, name them, as well as methods to decompose a time series into its components. The first main component, the core of the time series, is the trend. It's the overall direction of the data. So for instance, you might have a linear trend, a line going upward. Or you might have a curvilinear trend, something going up and then slowly slowing down, for instance. Then the second important pattern is a seasonality pattern. These are very repetitive patterns and they are regular, they are predictable. For instance, we can see if we look at attendance at the business school that every weekend there are fewer students in the business school. This is very regular, every 7 days, and this is predictable. This is a seasonality pattern. There are other kinds of variations that might also go up and down over time, but that are less predictable, and these are called cycles. They are usually longer term shifts. They have various length, and they are unpredictable. So we might be in an upward cycle, so we might be a bit above the trend, but we don't know how long it will last and when it will come down. Finally, we have the noise, and the noise is just the random deviations from these patterns that we've just mentioned. To illustrate these various components, I'm going to use the US aggregate retail sales, so all the sales in the US in retail. The data is at the monthly frequency, so each of these points is the aggregated sales in million for the current month. And you can see that we have a roughly linear trend. It's going upward at a constant rate on average. However, we can see that there are points that regularly are way above the line, and these points are December because sales tend to spike in December, and then people spend a lot of money and sales crash in January and February, and that's why we have also points that are below the line every January and February. These are seasonal patterns, so this is the seasonality component. Then we can see that it was going upward at a slightly increased rate compared to the red line, and then it crashed in 2008 with the depression. So that's a cycle. We couldn't predict that the depression was going to happen, or unless maybe you're really good at economics and you saw that coming, but otherwise we wouldn't expect it to crash specifically at that time. And so that was a cycle, and then it came back up slowly to come back to the general linear trend. And finally, the random variation from all these other components we've just described are just the noise components. So let's talk more about the trends. Again, the trend is the core of the time series. It's the overall direction of the points in the data. It can be qualified as the rate of change in this direction from period to period. The main common examples of trends are the linear trend, which is just a line, can be going up or down, and it means that the rate of change is constant between periods. Then we have the exponential trend, which has this increasingly upward curvature, and it means that the rate of change between period is getting faster and faster. It's increasing. So from period 1 to 2, we have a small increase. From 2 to 3, we have a larger increase. And as we move forward, we have a larger and larger increase. It is an exponential increase. Then we have the logarithmic trend, which is the contrary. It's a decreasing rate of change. So we have a large change from 1 to 2, and then a smaller change from 2 to 3, and it gets smaller and smaller as we move forward in time. Finally, we have the S-shaped trend, which is kind of first an exponential trend, then it slows down to a linear trend, and finally move on to a logarithmic trend. So the rate of change in that case is first accelerating and then starts slowing down more and more. All these patterns are very common in most business time series, and so you should learn to identify them and work with them. So first we have the linear trend. Again, the linear trend is when the dependent variable in a time series changes by a constant amount on average for each period. So in that case, we can use a simple linear regression model where the dependent variable is just the time period. And t starts at 0, it's the first observation, and then we have t equals 1, and so on and so forth until t is equal to t, which is capital T, the last observation. In that case, beta hat is the average rate of change or the average amount of change expected in each period when you move to the next period. So what happens if I take the US aggregate retail sales data and I fit a linear trend line, a linear model to it? Well, I can see that the model fit on average the data pretty well. And I can take the residual from that model, so the difference between the observed value and the line, and I can plot the residual on the right. We can see that we still have patterns in the residual. We still see the seasonality, which with each December being way above the 0 line and the January and February being way below. So we still have the components such as seasonality and cycle, the crash in 2008, being visible in the residual, but we have extracted the trend. So we started our decomposition of the time series into its components. We have the trend on one side, and we have the seasonality cycles and noise left in the residual. Now, when the trend is not linear, you can use transformations to capture the kind of trend you're facing. So if it's an exponential trend, you can apply a log transformation to the y variable. If it's a logarithmic trend, you can apply the log transformation to the x variable. In that case, it's a time period. And finally, for the S-shaped trend, you can fit a polynomial transformation. So I have t squared, and t cubed in your data that will allow for some positive curvature at some point at the beginning and negative curvature, so a slowing down rate of increase at the end.